So on today's notes, you'll see there are 9 problems there on today's notes. The assignment for this weekend is to finish them. I think we're gonna get through 4 of them, and I'm gonna let you the rest of the probably half the class to finish it yourself. All right, most of the kids are first period finished, so we'll see what happens in here. The topic is density. And from what I asked you guys yesterday, and period 1 said the same thing, that they've done it in science class, but that doesn't mean anything to me. I'm going to assume you've never seen it before. So, and I know some of you guys do this little triangle too. I've seen something. Something that looks like, okay, do whatever you feel comfortable with. All right, I'm going to give you a formula, but if you like this little triangle thing going on, I have no idea what it means, but if it works, it works. I'm fine with it. The formula for density: mass divided by volume. All right, mass divided by volume. That is not on your formula sheet, so I guess it is the one you're going to remember if you need to remember it. Here's the thing that's going to happen, though. In these word problems I give you, sometimes I'll use the word density and say the density of this object is this, but most of the time I'm not going to use the word density. You have to recognize that number in the problem is density. And how do you recognize that? It's always going to be a mass, grams, pounds, kilograms, divided by volume. And as we know in this unit, volume is always left in what type of units? Cubic units, all right? So that's how you know a number is the density. It's going to be mass, some type of mass, over the volume. And volume's easy to recognize, right? Because it's always cubic. And you'll see some of those problems in a minute here. But that's what we're doing today and Monday. All right, it's a 2-day topic. Monday is a much tougher, so hopefully you'll be here on Monday for that class. But density, mass divided by volume. Any questions? Why did I give you all these conversions, which are also on the formula sheet? You won't need them today, but we need to convert starting Monday. All right, we're going to have to convert units over before we find density. All right, so let's take a look at this first one here. Let's jump right into the old density topics. All right, we got a wooden cube. We have a wooden cube with an edge length of 6, and it's got a mass of 137.8. Let's determine the density first. All right, what's the density, and then what type of wood am I working with? All right, so go right to the formula. Density equals mass over volume, or if you use the triangle, guys, again, whatever makes you comfortable. We're looking for the density of this cube, so D equals, everyone see I gave you the mass already, 137.8, so that goes in for M. And this is what you're going to have to do for most of these density problems. And this is what I've been training you for all this unit, which is now find the volume. Okay, figure out what type of figure it is, go to your reference sheet, find the volume. Okay, find the volume. This is a cube, also known as a prism, right? Cube is just the same as a square prism. So we're going to do BH to find its volume. And now I'm going to turn this over to you guys. What do you want to multiply together to find the volume of this cube? Here we go. What am I multiplying together? Might have to call on a couple numbers here today. A lot of vacations going on, I guess. Alexi, what do you want to multiply? Yep, it's a cube, all length, width, and height, all the same. 6, 6, 6. Good. And we're finding the volume is 216, centimeters cubed. All right. We go back down to our density formula. That's the volume. Plug it in, 216. And now we calculate the density. Rounded to the nearest thousandth on this one, 1,000. So that would be 3 numbers after the decimal. Look at the 4th if you have to round or not. So what do you get in there? Calculating the density. When you're ready there, Jonathan, what do you got? You got it, 0.638. There's my density. And then there's a second part of the problem, which is what type of wood am I using? Looking at the table. I don't need to ask anybody. We're using some ash wood. Anybody know their woods pretty well? Like if I just put a slab of wood right on your table and you maybe look at it, touch it, sniff it, and you tell me what type it is. Anybody that level? You are, Dylan? You're at that level? You could tell me up. That's birch right there. Good. It's a good skill to have. You know, I would have no idea. Questions? Anything else? All right, good. Let's keep going. Oh, a little shipping container. Those are things on the boats there. Rectangular prism we're working with. You guys see the dimensions? And when I fill it, it weighs on average 0.25 pounds per cubic foot. Remember what I was talking about earlier? Hey, 0.25, right here. 0.25. I don't come out and say it, but does everyone see the labels I put with it? Pounds per cubic foot. What's the 0.25 in this problem then? What is that? I didn't come out and say it, but look, pounds per cubic foot. 0.25 is the what? That's the I'm not going to come out and say it. That's the density. Because look, it's mass pounds per volume cubic foot. Is everyone all right there? That I am giving you the densities 0.25. And we're looking for what's the weight in pounds. So we're looking for mass now. We're looking for mass. So if you look at your formula, density equals mass divided by volume. Substitute in 0.25 for D. That's my density. And I'm not going to give that to you. I'm not going to say, hi, I'm the density. We got to recognize that. And what are we solving for? Mass. And I told you the last problem. This is what all these problems involve. Find the darn volume. Find the volume. Know what figure you're doing. This is a rectangular prism. So again, let's use BH. And let me turn this over to you guys again. How do you find the volume of this rectangular shipping container? What are we multiplying together here? Vinny, what are you multiplying together?
12, 8.
Good. 12, 8.5, and 4 to find the volume. Let me know the volume when you get it. Zoli, what's the volume when you have it? Where did that? 12 times 8.5 times 4?
Volume equals 408.
408, yep. All right, everyone, let's go over here. Plug that back into the density formula for your volume. Now, how do you solve? You can cross multiply, right? If it makes you feel warm inside, put it over 1 and cross multiply. To find our mass, and there are no rounding directions because none are needed. What's the mass of this shipping container, Stephanie, when you have it?
102.
There you go, 102. And let's just take a look at our units. We're doing mass here, so it should be 102 pounds, lbs, as we say on the streets. Not that big of a shipping container. What?
I said I was about to say. Seems like pretty small.
Yeah, you got something in common with it. It's frail. Good. Anything else? We good? Too harsh already on a Friday? All right, now we're going a little bit bigger now. American white oak. Ever seen one of those bad boys, Dylan? Good. All right. Yeah. 752. What's that 752? Let's talk about that. Kilograms per cubic meter. What am I giving you with the 752? Is everyone okay? I'm giving you the density. Actually, I just said density. It just said density, so why am I even bother talking? Why am I writing it too? It's ridiculous. Yep. Ooh, now I'm giving you the circumference of it and the height. What's the number of kilograms in the trunk? All right. Density, mass divided by volume. Substitute in 752. What are we looking for? The number of kilograms. So we're looking for the mass again. All right, volume is going to be a little tougher to get to now. First question for everybody. I got to figure out what formula I need. What the heck is this tree here? I'm not going to come out and tell you what the figure is. It's not a rectangular prism this time, but it's going to be a what? It's going to be a cylinder, right? Tree, cylinder. So I go to my formula sheet. I'm going to find the volume of that tree by doing pi r squared and its height. We run into a big problem. The only thing I gave you that could be substituted in is the height. 8. We do not have the radius of this tree. True, but we do have the what? Circumference. All right, let's keep talking now. Let me go to step 3 here. We do have the circumference. And if that is also on your formula sheet, and I know there's 2 formulas, but we've always used pi d in here. So I'm going to keep using that. So everyone see how we can get to the radius now. Get d by itself, cut it in half, substitute it in. Everyone all right with the plan? All right, so substitute in 4.5 for the circumference. Pi d. Unfortunately, no pi's on both sides, right? No pi's on both sides, so we got to get rid of it another way. How do you want to get rid of the pi now? So I can get d by itself. Ho, Lauren.
Divide it.
Yep, divide both sides by pi. All right, so I'm going to say d equals, and here comes a decimal, I'm not rounding. All right, there's the diameter of the tree. But again, remember we need radius, so let's cut that beast in half. Everyone's cutting it in half and getting, let's see here, I got 0.7 and change. Substitute that in. Everyone comfortable getting the radius from the circumference? We're good. And now go ahead, calculate the volume. Again, don't round it on me. You can leave it in terms of pi if you want. I don't know if your calculator will do that, but I'm sure it will. You can either write out the whole volume or leave it in terms of pi. So here's what I'm getting for the whole volume. 12.89155039. And substitute that in back into the volume. It says approximate number. Let's go nearest whole number here. All right, nearest kilogram. When you guys multiply, nearest kilogram. And what are we getting here? Nearest kilogram. Char, what do you got? Nearest kilogram. 9,690. Got it. We were trying to figure out last period, because we don't really deal in kilograms in this part of the area. It's about 21,000 pounds, we figured out. About 10 tons. It's a big tree, ladies and gentlemen, big tree. We're dealing with big tree, not that you care, but. All right, one more. Tanks, here we go, hemispherical tank. We're gonna fill that beast with water. That's what water weighs, 62.4 pounds per cubic foot. What's the weight of the tank? What's the weight of the tank? Anybody on this 62.4 pounds per cubic foot I'm giving you? Yep, there it is, without even saying the word this time, density. And this is what many of these problems I'm going to give you involve is, how much does it weigh? We're trying to find the mass. All right, ready for the volume? Determine what the figure is. It's a hemisphere. All right, that's not on your formula sheet, but a full sphere is, right? Full sphere is on your sheet. 4/3 pi r cubed. Please use your darn sheet. Drives me nuts when I see pi r squared there. Why? It's staring you in the face on your formula sheet. Now cut that in half, or I like to multiply it by a half instead of dividing by 2, but whatever floats your boat, find your loss remote. All right, calculate the volume. Make sure we're using 5, not 10 for our radius. What's my volume here? 261 and a little change. Nearest pound when you have it. This thing's a beast. Beast. Henry, how big is this thing? How much does this sucker weigh?
16,336 pounds.
Woo! That is a tank. Water weighs a lot. All right, any questions? That's where I'm ending it. That's our discussion today. Answer key out up on Classroom, get it out. So you make sure you're doing these right. 5 through 8, pretty standard, straightforward, just like we did. 9, you're gonna have to work at though. All right, 9's a little bit tougher. Don't give up. Call me over if you can't get anything, please. And remember, hey, you just want to copy my work off of Classroom. Hey, good luck on Thursday, right?